Welcome to the Lighting Best Practices for Efficient Indoor Agriculture. I'm Rob Eddy, the Technical Director of Resource Innovation Institute. We're so glad you're here. I've been looking forward to this workshop for a couple weeks now because we just got a great panel for you, and this is material that's up to date and relevant and has such an impact on your facilities. So I will get us started today, and we'll go through a little bit of introductory material about who RII are, and we will introduce our speakers, and then we'll get into a technical discussion, and that will be followed up by some information from Christopher Scott at SCE about incentives that are available in the California area and their region of SCE, and then we'll open it up for question and answer. Also, during the talk, after each section of the technical discussion, with Kenda and Casey, we'll also open it up in case there's something that you want to ask right then. And of course, as typical with our Zoom webinars, you can ask us questions in the Zoom chat or hit the raise your hand button. And if I don't see it in the participant window, then Carmen, who's working with me, will see it and remind me. Okay. So our agenda today is of course the introduction. Here are some of the topics we'll be covering for the lighting talk, and then, like I said, SCE lighting incentives. Okay, allow me to start by talking about RII and who we are. We are a data-driven nonprofit organization focused on research and advocacy to improve resource efficiency of the CEA industry. A little history about us. For the first 4 years, RII served primarily the cannabis industry, providing objective, non-biased information, along with providing some policy guidance. And this is really a great thing that RII did back when the industry really needed that help. Didn't have a lot of sources of objective information. In 2020, we received a USDA grant to apply our expertise in climate policy, utility programs, and green building certification, and so forth, to the CEA industry. So our focus in the last year and a half has been towards CEA crops, but of course we serve the cannabis community as well, because we're all one group and we benefit each other. Our mission is to measure, verify, and celebrate the most efficient agricultural ideas. We develop key performance indicators using data gathered from growers in our PowerScore software. PowerScore is our tool to help our members verify that using best practices indeed works to reduce emissions while maintaining or improving their canopy productivity. So we are equally focused on your business success and the success towards resource efficiency. We also develop case studies that help us promote the success producers who've used best practices, and that enriches the data, in turn helps to create sound policy recommendations. We're well connected with all the players in the market: growers, supply chain, utilities, local government, academia. That's why we're capable of getting friends like Kenda and Casey to join us for these panels. We produce and publish best practice guides, then educate based on that content by providing workshops, seminars, roundtables, conferences, writing articles in the trade journals of several industries. We believe bringing all these people to the table can transform the industry into a more resource efficient one, more so than any of us could do alone. So the way we write those best practices guides, and right now I'm in charge of one for water circularity, which is really fun because I think it's one of the first of its kind. So we form these working groups of vendors from the supply chain, academics, and even regulators. And what we do is we distill their expertise into the form of the best practices guide on specific subjects like lighting or like HVAC or water circularity. This workshop is based on our most recent BPG for lighting. The Technology Advisory Council shapes the scope, outline, terminology, key issues when we're writing these best practices guides. But they do it it's great. They do it in a brand agnostic way. So the members of these working groups all together, which is called our Technical Advisory Committee, they take off their company hats and kind of put on an industry hat, which I think is really rather remarkable. The CEA industry, this young in the cannabis industry, this young is willing to share information as much as they do and collaborate. If this sounds like a role you'd like to take on, you can become a member of RII and join us on these working groups. And we've got a full library of these best practice guides. A lot of them are available for free because they're sponsored by the USDA. This year, we published the guide for CEA design and construction, as well as for HVAC design, installation, and maintenance. In 2023, we'll publish the one on water circularity and also one on CEA controls and automation. And we have one for lighting, which is for the cannabis industry, but of course, it's relevant for any grower for the most part. So what will happen is today I'll be presenting some slides from that best practices guide on lighting, and but also Casey and Kenda bring us information and charts from their own work and their own designs. So this is going to be really great because it's a real diverse set of information. You're not just getting one person's mind, but several. And you can download these guides. Again, most of them are for free from our website. And Carmen has put the link to this in the presentation. And if you have any trouble getting to those, just let one of us know. Okay, Carmen, can I ask you a question? We've got a note from someone that my screen is blank. Can you see my screen?
I can see your screen just fine.
Okay. All right.
And she can see the screen now too.
Oh, now she can see now. Great. Thank you. Thanks, Carmen. Thanks, Jewel, for letting me know. So today's speakers, Kenda Branch from Hawthorne and Casey Rivero from Fluence. I'm going to have them introduce themselves. First Kenda, then Casey. I'll tell you a little bit about myself just to get it started. Again, my name is Rob Eddy. I've been with RII for 4 months. Prior to that, I was a consultant in the cannabis industry and the hydroponic and ag chem firm business, kind of a broad spectrum of clients there. And for 20 years, I was the plant growth facility manager for Purdue University's horticulture research greenhouses. So I've got a lot of applied background, but also had to be well-versed in all the plant science going on around me so I could translate that between professors and our team. And prior to that, I worked for Dow AgroSciences, a big corporation, for 4 years in their research greenhouses. So kind of a diverse background, but I'm so glad to be here. This is such a fun group to work for and a part of a mission that I want to be on. Kenda, why don't you please introduce yourself. Tell us a bit about yourself.
Sure. My name is Kenda Branch. I've been with Hawthorne for about 3.5 years. Before that, I came from the safety testing and certification side of the lighting industry. So I've handled a lot of different types of lighting products and worked in various lab environments. And then kind of got my start in lighting design, specifically with outdoor and commercial lighting, and just been with the cannabis industry, transferring that, that knowledge as best I can to this sector.
Great, thank you, Kenda. Casey?
Hey, thanks, Robert and Kenda. Casey Rivero, and I'm a cannabis solutions architect at Fluence, and I've been on the team for roughly coming on 4 years now. It's been a wild ride, fun, and prior to that, I owned and operated facilities in Oregon and California and Arizona. So I've had the chance over the close to 20 years to see a lot of really good things in the cannabis industry, and also a lot of the struggles that we've had to go through to learn what we're about to teach y'all in this webinar today. So had the pleasure to be on the technical advisory committee since 2016. So I've also had the chance to watch RII grow and expand to what it is and what it's becoming. So It's an absolute pleasure. Thanks for having me.
Great. Thanks, you two. I should also mention that we did have scheduled Casey Holland from Design Light Consortium to join us, but he couldn't make it today because of family issues and health. So I'm going to move on now, and in Casey Holland's slides, we're going to be presenting as well. Oh, lost one. So a bit about the industry background for California, and of course, it's easy to talk about California cannabis because they're number one, massive industry with over 6,000 cannabis cultivation licenses for specialty cottage, specialty, small, medium, large, outdoor, indoor, mixed light, a $4 billion legal market. And I believe Carmen has told me it's an estimated $8 billion illicit market. California is also number one in most other horticultural products. It's usually them or Florida vying for top production ranks. But food and floriculture, you can see the largest tomato growing area, largest berries growing area, largest vegetable, and a massive mushroom production. In floriculture, second only to Florida, like I said, and large nursery crop area, and second largest for cut flowers. So long history of great horticulture coming out of California. Purpose of today's workshop is to encourage cultivators to participate in Southern California Edison's efficiency programs. And again, we'll be talking about those later on. And of course, we'll be conveying scientific and industry insights. That's me and Kenda and Casey, and the best ways to translate them towards your facility in the local ecosystem, and to help those energy efficiency programs achieve their savings goals through education and knowledge. So it's a really great union of all these purposes into one webinar that it's a win-win-win. You can access our California virtual classroom that has more than just this recording. It's got tip clips and downloadable resources and programming tools from SCE and PG&E. You can register for upcoming workshops. This is the second out of 4 for this series. And the next one will be optimizing CEA environments on November 8th. And then on December 13th, controls and automation best practices. Okay, so I'm going to get into the technical discussion now. Again, at the end of each section, I'll stop and see if we have any questions, or we can save them until the end. And don't forget, you can just write them in the chat. So the first part of the technical discussion is how CEA crops use light. So one thing, let's start from the beginning. The light that plants use is a part of the electromagnetic spectrum, which has UV light and heat, all this stuff coming from the sun, including heat, infrared. But this narrow part, which aligns pretty closely with human vision, not perfectly, is the part that plants are responding to. And so for photosynthesis, plants really respond to the blue portion of visible light and the red portion of visible light. You can kind of see those peaks there. And the other portions, as we'll discuss on the next slide, can also have implications as well. What's been really fun and exciting about light is all the research that's been coming out because of LEDs. And one of them is that now we're at the verge of expanding our definition of what this photosynthetically active radiation is. We've been saying 400 to 700 nanometers since like 1950. And now we know that, hey, actually it goes beyond 700, and just some fascinating research that isn't just curious academic stuff. It really applies to how you can grow plants. So we talk about photosynthesis being in the blue and the red part of that PAR spectrum, but the other parts do other things. They might contribute to photosynthesis and other things. And I know this is a very busy slide, but let's just touch on some of the things that these different segments of the electromagnetic spectrum can do. They can cause plants phototropism, to lean towards light. That's in the UVB range. UV light, I think, as you all know, can also be used for pathogen control. And UV light, UVA and UVB, can stimulate secondary metabolites. Now, what the heck is a secondary metabolite? First of all, primary metabolite is something the plant needs to grow and reproduce, complete its life cycle. So, just about DNA, cellulose, all those things the plant makes in order to grow and develop. A secondary metabolite isn't necessarily needed by the plant until it needs it. So it's a defense compound. So when the plant is exposed to a stress, that will activate new proteins in the plant. It'll create these secondary compounds to defend them against bugs or disease or high light or drought, you name it. And what's relevant to all this is these secondary metabolites include cannabinoids, terpenes. It includes all the stuff that makes food taste good and look good, the flavonoids and the pigments that make eggplant purple and red lettuce red. Green light is kind of exciting because we're now realizing that, hey, this actually does help with photosynthesis, and it penetrates further into the canopy than red light does, because it just doesn't get absorbed quite so well. So you can kind of use that to your advantage, and maybe a good reason to have a broad spectrum LED light. But don't let me talk about LEDs. I'm not the expert here. We'll let Casey and Kenda talk about it. And again, far red has now been shown to improve photosynthesis as well. But in nature, what far red light is how the plant senses that it's under the shade of some other plant, and it makes it stretch to get taller, and makes its leaves get broader to try to absorb more light photons. Carmen, are we still good? I'm not hearing.
Yeah.
Okay,
You're
great.
still good.
Thank you. Okay, so also key terms for plants is the difference between PPFD and DLI. Now, it's the way to think about this is think about light coming from the sun. Think of them as like photons of light, or just like raindrops, okay? So the intensity, the PPFD, is what that rate of photon rain is, okay? How many of them are coming down over 1 square meter per second. So and DLI is more like having a rain gauge and be able to measure how much is accumulated over the day. All right. So PPFD is the intensity at that moment, which you measure with a light meter, either handheld or desktop. And a DLI would be measured by a sensor that is essentially measuring all day long. It'll accumulate all of those measurements and tell you how much is accumulated over the day. Photoperiods for plants. Some plants respond to the length of the daylight or lighting period if it's artificial lights. And there's a lot of species of plants that are day neutral. They really don't care. They will flower whether it's a short day or long day. But some plants need that long day in order to flower. And a lot of plants need a short day to flower, including cannabis and chrysanthemums and poinsettias. It's usually around 12 hours. And there's some differences between species and differences between cultivars and poinsettia and cannabis, but that 12 hours is usually the critical amount of time. And of course, as I discussed, phototropism is the orientation of plant towards light, which you've probably seen with your house plants near windows. So lighting impacts on growing environments. This is really, really important to understand, is how these interactive effects. Unfortunately, growing plants, as you all know, is not easy. There's a lot of gray area, but there's also a lot of moving parts, okay? And this is one of them. So the lighting systems can affect the HVAC, the irrigation, which of course could be your fertigation. The light, if you're in a greenhouse, the curtains are going to be responding to that changing light. There's just a lot of things going on. It's just it's a real dynamic system. Okay, before we go on, I want to see if Kenda or Casey can add any insights that I didn't cover during those two sections. Anything else worth mentioning?
Everything sounded great to me, Rob.
Okay, great. Carmen, Did I miss any questions from I don't see any questions in the chat. Did I cut you off? I'm sorry.
I was just
there were any questions missed.
Right, great. All right, let's move on to the benefits of LED lighting. So Casey, why don't you take this one away? Oh, I'm sorry. This is just the first section. I'll do this one. So when you have LED lights, you're going to be operating differently. Okay, and let's talk about some of those things. You can mount them closer to the plants than you've ever mounted lights before, especially if you've used high pressure sodium. You probably noticed that you got within 36 inches that you're just going to burn your leaves or flowers. This allows you to go vertically in racking systems, of course, and you can also meet PPFD targets with less fixtures because you got them closer to the plants. Wonderful thing about LEDs is no bulbs to change, okay, and that makes a big impact. If you've managed a greenhouse like I have, changing bulbs is just a freaking nightmare. You're up on a ladder, you got to move tables to get up to it. And if you have to change a fixture itself, those fixtures could weigh 30 pounds or more, and it's almost death-defying kind of work. And of course, it takes a lot of time, and all that evaporates with LEDs. And we could be putting LED fixtures up, just holding it up with one hand, whereas a heavier metal halide or high pressure sodium, you're up on a ladder with something that might weigh 20, 30, maybe even more, and you got to hang that on something. LEDs can be cycled on and off rapidly, whereas other lights can't do that, or at least it's really not good for the starters or the bulbs. And LED fixtures can be dimmed very exactly, and therein lies a way to unlock energy savings. More on that later. Of course, you can save energy and reduce utility bills with LED lights. Here's a great chart comparing the cost per year of operating different kinds of light. And with the high-end LEDs, you get the best savings. And also, I want to point out that these LEDs on the far right of the chart have an efficiency, meaning how much light they produce per unit of energy that's applied to them, have an efficiency of 1.8 to 3.0. And the reason that I've got those numbers emboldened is in California, the Title 24 code changes now say that luminaires have to have, that's their term for lights, have to be 1.7 micromoles per joule. So basically, you will not be able to build new facilities without using high-end LED lights. You can steer crops with LEDs because you've got ways to dim, you've got ways to change the spectrum, and you can provide specialized light recipes for different cultivars or different crops. Again, we talked about being able to lower those lights closer to the plant, and I'm sure we'll talk about this more later, but there's a rule of thumb that has been around from greenhouse growers for probably 2 decades now. It's really been proven scientifically in the last 10 or 12 years that for every 1% increase in light intensity, you can get a 1% increase in yield. So the better you can do with applying more light, or even better, applying more light, but also in a way that plants can intercept it, then you can get higher yield. And by intercept, I mean you can get them closer, or you can get them a range so the leaves are absorbing more of that rain of photons, then you're going to get better yields downstream. Spectral treatments, meaning not just having this broad spectrum white light, but having different colored lights emphasized, like having a lot of red or a lot of blue, depending on the kind of light you've purchased. Those can impact taste, structure of the plant, and the pigments of fruits. And it can also help with pathogen management. The one thing I would say is the effect of light spectrum on plants. It is quite remarkable, but it tends to go away as the light intensity decreases. So you see those spectral effects at lower light intensities, and once you get to high light intensities, they begin to not be so evident. Of course, LEDs have an effect on the HVAC system, and it's quite impactful. that you can, because they don't give off so much heat, you don't require so much cooling. So now you may not have to buy as large of an HVAC unit. That is large. By that I mean the amount of tonnage will be reduced. So in a lot of cases, depending on how your whole light setup is, your lighting solution is, you might not have to spend so much to buy the HVAC. But no matter what, you're going to save operating costs, because LEDs, you're just getting more light per unit of energy. So it's just more efficient. So there's some estimates of a 33% lower HVAC system capital cost. And then you're going to have operating cost savings as well. You're going to maintain these LEDs differently. No bulbs change out. And I was talking about how great it was that they were lightweight. LEDs can maintain their light output for much longer than traditional horticultural lighting. I think if you've grown for a while with HPS and metal halide, you've experienced the HPS kind of turns you can kind of begin to see it when it gets really bad. The light is much more orange looking. You might get some flickering with metal halide. It's not so visible with the color. But one thing that metal halides, if they kind of have a safety problem sometimes, that if they are manufactured with some defects, they will explode while being used and send this white hot glass all over your facility. Trust me, I've seen this. I've seen the fires started by this. Nothing that burned down the building, but it set a lot of plastic trays on fire and would have been a real nightmare had we had anybody working in the room at the time. Questions about that? Or Kenda, did I miss anything?
No, I don't think you necessarily missed anything. I will elaborate on some of that in my further sections.
Great, that's right. You'll be covering more of that. Wonderful. Mm-hmm. Carmen, any questions? Anybody raised their hands that I'd missed?
Nope. But PG&E, which is the other largest utility in California, has offered their borrowing and lending tools where they have some light meters that are available.
Oh yeah, that's right. Thank you for reminding us of that. Thank you, Mary. We want to promote that as much as we can. You just don't see this too often, where an organization will allow you to borrow their tools. In that way, some of these things are, well, most of them are extremely expensive. So it serves everyone if we can just act as a community and borrow tools, take good care of them, and sensors and monitoring systems, and all use them. So thank you to PG&E for that. Okay, now we're going to move on to the next topic of optimizing lighting system design. I'm going to let Kenda take it away.
Thank you. I will just apologize in advance. I do have two very upset dogs that they are not allowed in the office right now. So if you hear any whining or crying, that's them barking. Apologies. But yeah, in this section, I'm just going to be talking about some of the design considerations necessary for purchasing your lights that can factor into what you'll need for your grow success. First thing, we all know that not all LEDs are created equal, and there's a lot to consider before purchasing and installing the lights. The ideal application of the lights might be the most important. The photometrics are typically designed for specific applications. Variations in optics and spectrum can be specific to a type of crop or crop stage. When it comes to the fixture components, such as ballast and drivers, some LED bulbs can work with existing ballast, while some utilize internal or external drivers. Some fixtures have existing controllability functions for dimming, intensity, or tuning spectrum, while others work with external controls. Additional differences specific to the manufacturer when it comes to maintenance, support, and warranty. This should be considered before commissioning and installation. Third-party certifications, like for DLC or even for something like Title 24, while it may not necessarily factor directly into what you're trying to accomplish, it can factor into the types of fixtures that are needed to meet certain energy efficiency requirements. And then before we move on, I'd just like to quickly circle back to photometrics. This is something that's kind of not necessarily always been in the forefront for horticultural lighting, but is important as it can factor into not only how many fixtures and how much light, but also where they're placed. This becomes particularly challenging, or can be, when you're retrofitting an existing project. LED fixtures, HID fixtures, a lot of them have this sort of batwing rectangular distribution profile, and there are some LED fixtures out there with a similar profile, but they're not as common as the omnidirectional Lambertian distribution profile that exists with so many of the rack and bar style LED fixtures. But as more growers are switching over to HID and LED, placement of those fixtures can affect both the lighting intensity and the uniformity. Most of the photometric details can be found in spec sheets or online on organizations like the DLC, but that info is not always sufficient for determining your setup, especially if you're trying to match a previous setup. And so this is where getting a lighting layout can be extremely helpful. Next slide, please. So I'll talk briefly about lighting trends. So I've been involved with, doing lighting designs, not just in horticultural lighting, but outdoor and commercial as well. And so while at Hawthorne, my team and I, we've done thousands of designs for hundreds, if not thousands, of growers. And in the past few years, there's been a couple of trends that we've all seen as both the LED market and the cannabis market have grown and expanded. When it comes to how growers are growing, and we touched on this a little bit earlier, the vast majority are indoor as opposed to greenhouse. But whether or not you're growing indoor or in a greenhouse, energy costs are still a big challenge. So this isn't going to be going away anytime soon, but growers are responding by making the switch to LEDs. As efficiency is improved over the past several years. 5 years ago, most of the requests that we were receiving for lighting designs were for HPS and CMH designs. Most growers aren't using LEDs like they are now, with the majority not just in flower, but in veg and propagation as well. So when you able to get more bang for your buck for this technology that lends itself well to setups for multi-tier operations, it's not surprising that you're seeing an upward tick in vertical farming. And even if the majority of these growers are still working with single-tier operations, many of those highly efficient rack-style fixtures are still suitable and preferred for their grows. Some of the other trends that we've seen, based on what growers find important, and more and more are valuing dimming capabilities, higher light intensity, and a lot more concerned about light spectrum. And this kind of all points to controllability considerations. This should all be happening before you're purchasing fixtures. As I mentioned before, not all LEDs are created equal. They don't all dim down to the same extent, which can factor into what crop stages they're best going to be suited for, or how many you'll need. They don't all have the same output and distribution. That can affect light intensity values at the crop level and uniformity. They don't all have the same spectrum. So they're also not going to have all the same spectral tuning capabilities. So that all factors into, your ideal setup. So the dimming capabilities, light intensity, spectrum, can all be confirmed with a lighting plan. It should really happen prior to purchasing if you're available, if it's available for that. An example would be, how this can save you costs is, say a grower is looking at a par map, in a spec sheet for a 4x4 rack style fixture, and they decide they need one fixture for every 4x4, roughly 4x4 section. And then they purchase that amount of fixtures. And so, yes, just making sure the lights are dimmable if you're, requires specific light levels that is definitely can be the end of the solution. But for this example, if you had a light map that could confirm that there's too much light, say for instance, for what you want, like say it's for veg or mother, manufacturer can present a design with actively dimmed light scenes that represent this reality, and alternate designs with even fewer fixtures, maybe that are more spread out or raised up a bit, so that could potentially result in more ideal light levels with fewer lights. That's saving you costs in the end. So nowadays there's a fixture out there for just about every growth stage, and working with the manufacturer, make sure all the needs of your crops are met. Best ensure that you're providing crops with ideal light intensity. It can also minimize your energy consumption and lower your bills. Next slide.
Kenda, does a client have to pay for that light map that you described?
It depends on who you go with. The distributor, the manufacturer, whoever is providing it, it depends on whether or not they actually charge for that kind of service. So I know at Hawthorne, for instance, we don't. So it just
Great.
boils down to who you go to.
All right, thank you.
So 3D modeling. So many of the lighting manufacturers that do offer, lighting layouts, whether it's, just one room or an entire facility. Most of the lighting software developers out there, you've got Lighting Analyst, Autodesk, Dial, those are the three that I'm most familiar with. They've been around for several decades, sort of fine-tuning to various IES lighting standards. But designs for the horticultural industry are a bit newer. Not all the software can even convert to, or does convert to lumens and par, lumens to par, lux to PPFD, etc. But nevertheless, the service still exists. The conversions can happen in-house before actually applying the photometric files in the software. So there's variations in what the options are, but for the most part, these designs can include and confirm your site plan details, as well as how many lighting fixtures, additional hardware, how that's going to work within your space. Did you have a particular fixture in mind, but your room has columns or wall jogs that are going to break up benches and racks or fixture rows? Did you have a particular fixture that you had your heart set on, but you have low ceilings? You've got ductwork and HVAC equipment or fans that might be kind of interfering with your lighting. Do you have certain egress requirements that lessen the overall canopy that you preferred? Does that result in having to move from single tier to multi-tier? So these are all examples of situations that can kind of be worked through once you have the lighting plan. And that can be much of a hassle if taken into consideration before you bought the lights. So another aspect real quick of 3D modeling software is being able to render the lighting according to the photometrics. So I remember when I first got started in this lighting software, it didn't really matter what the technology was. Cool white, fluorescent, warm HID, purple LEDs, everything looked identical. But nowadays it's kind of as simple as just including colorimetry info in addition to your photometric files, and the software can kind of show the difference in those light types and spectrum, depending on the software. That's not only going to affect your plants, but it can also, affect the human experience working within these rooms. And I'll just talk once again real quick about retrofit projects. So growers don't always know what lighting they're working with when it comes to the distribution profile, specifically with a lot of the older HID fixtures. Many of LED manufacturers will provide, PAR maps, which are great for understanding light intensity expectations directly under a single fixture. Many will provide a polar plot that will give you an understanding of the fixture's footprint. But unless you have a photometric file, what we call an IES file, and have used it in lighting software, you're not really going to have the best idea of how it's going to work within a full setup, how many lights you're actually going to need, how they should be spaced, how they should be mounted, where they should be mounted, etc. Next slide, please. So most of the photometric light reports, based on the 3D modeling we discussed, they will present a variety of data that can include those 3D renderings, but also information such as your average PPFD, your uniformity, and your heat maps. All of this is related to each other. The average PPFD is based on calculation points taken throughout the canopy and will typically include minimum and maximum values. Uniformity calculations, there's a number of ways to calculate this, and it can depend on lighting applications, especially in the commercial side of things. But they're also based upon the average, minimum, and maximum values, no matter how they're actually calculated. And then the heat map, well, it's not actually showing levels of fixture temperature. It does present colors to show range of PPFD value across the canopy, which can help visualize light spread and highlight any fixture placement issues. You'll see uniformity would basically be represented kind of how it's shown here, where across the canopy it's pretty much the same color. You're not seeing any highs or lows, hot spots, as we'll sometimes call it. And then also ISO lines that can also be used to kind of visualize the light spread and highlight any areas with drastic light level differences by displaying those specific values along those lines. So the average PPFD, uniformity, ISO line details will also be shown at one or more heights indicated across the floor, above the canopy, or above the bench. And the results can sometimes highlight issues with crop height and or associated benches and racks. This can highlight, this comes into consideration when we're dealing with human workflow around the canopy. If benches are too low, we can highlight, airflow considerations when it comes to fan type and placement. If the lights are too close to the canopy, HVAC and equipment and locations if the lights are too close to the ceiling. All of these design components work together in harmony. So be sure to take it all into consideration, as you're going through these light plans. So the 2D portions of these designs are also what installers may refer to when implementing the room or facility designs. Details such as where to hang unistruts, where not to place fans, DHUs, ductwork, all of that part of the process before buying. And if an LED fixture, if you're swapping it in for an HID fixture, the 2D maps can kind of confirm your existing mounting locations and highlight any mounting issues. And lastly, they can include electrical info, your total wattage, your current, your heat load for the space. All of these specs, so that those details can be calculated. That kind of info, it can be necessary when it comes to confirming your electrical needs, making sure there's enough HVAC to accommodate And then sometimes that's required for submitting for your LED rebates. So keep that in mind. For that section.
And I don't see any questions in the chat at the moment. And so, forgive me, Kenda, were you going to do this, or is this Casey?
That's
Thank you. Yeah.
Okay, finance. So next is the next section is maximizing financial incentives, and so Casey, were you going to do this one?
Yes, sir.
Great. Go take it away. I'll I'll move the slides for you as you tell me.
Awesome. Appreciate that, Rob.
Mm-hmm.
So as Kenda and Rob have explained, there's a lot that goes into the proper planning of the facility in order to maximize production, but doing it in an efficient manner. You know, it's not just this measurement, this equipment, this, cultivation method, boom, success. You know, there's a lot of choices and a lot of analytics that go into, what it takes to build and design and develop and run a facility in order to achieve this success. So, and a couple of those things, that we need to really pay attention to is the financial implications and incentives that we come across when designing, but also running a facility, a commercial facility. And so, there's a few financial considerations that we tend to really look at as far as the predetermining factor on how we're going to design a facility. Obviously, crop type and market needs. We're going to build a completely different facility growing microgreens as we will with a vine crop, and so understanding what the crop requires, but not only what the crop requires, but what the market needs are, right? Developing in a market that is already oversaturated might not be the best business decision, developing in a market that, sells highly a product of this variety, when our business decision is a different variety, it might not be the best decision. So understanding what the market needs are is a first really important step, right? So then after that point, we needed to develop a business model, and the business model needs to be developed as your baseline and foundation for every decision moving forward, right? Almost similar to, our company profile. That business model really needs to stand firm in the decisions that we make moving forward, right? Whether we're going to grow for this type of product or this type of product, we need to understand what that model needs to be right off the baseline. Once we start to understand what market we're moving into and our business model that we're trying to move forward with, how are we going to utilize that space, and where that business is really kind of helps determine that. Cost per square foot of land is going up, resources are going down, and so understanding what space we need, that's required of us to achieve whatever outcome we're looking for is really important. And so how do we know what kind of space we need, right? There's a couple different things, right? In certain markets, there's a requirement or a cap on square footage or square meters of how big our facility can be, right? So in those specific circumstances, we're going to try and maximize as much as we can to that area that we're given, right? If we're not necessarily given a limitation, then we need to understand how much we need to produce or are expecting to produce for the market, and how much are we capable of that, and then build backwards from there, right? So knowing exactly, or roundabout of what our expectation is in the market for production will tell us how do we need to utilize our space moving forward for that, right? So the next consideration is, honestly, some people's biggest is how much are we spending on this project, right? What's the capital expenditure that it's going to cost me to install all my equipment, to pay for the land, for my employees, to actually implement this business model that we're trying to achieve, right? How much is it going to cost up front? And then the operational expenditure is a really big one, because that's your cost that you continue to pay throughout time, right? How much is it going to cost me to operate this facility in this manner to achieve what we're trying to achieve as far as, our business model and the market needs, right? We need to really be able to understand both of those to be able to move forward successfully, right? So now the last piece of that equation is understanding how fast are we going to get paid back for this project, right? And what does my return on investment look like? Most of us have to, search for financial backing, whether that be from, personal loans, equity deals, equipment financiers. We have to find this money somewhere. And so paying back that investment, as fast as we can is really important to a lot of business owners, right? And so that payback period and the return on investment really ties into how we make that decision for the capital expenditure and the operational expenditure, because that's what makes it make sense, right? If your payback period and your return on investment doesn't make sense, then your business model needs some reevaluation. And so everything has to tie back into a cyclical format to understand, are we operating our business at an optimal level, right? And an efficient level. So could we go to the next slide, Rob? Awesome. And so a couple strategies that we're seeing as far as indoor focused strategies for how we're going to develop a facility. We see kind of two different buckets right now. We're seeing new indoor builds, and then we're also seeing a lot of retrofits and expansions on current infrastructure, right? So there's a lot of licenses now that have been, older, more legacy licenses that are now being sold to different groups who are trying to update equipment, and or expand upon their footprint. So the retrofit and expansion kind of section, we're seeing a lot more these days, more than new builds. People are trying to save some money on existing equipment and just, optimize their infrastructure. So the first section, which is the indoor new build, there's kind of two different approaches people take. It's either single level, whether they have stationary benches or beds, or mobile benches or beds. And then the next one is multi-level, right? And same thing with the multi-level, you can either have stationary racking units, or you can have mobile racking units. And so those are kind of the two different choices within that category that we see people making. So now on the indoor retrofit and expansion side of things is somewhat similar, right? And so what we have to do as far as this industry is we're taking a look at efficiencies and based on a baseline, right? And currently the baseline in our industry has been HID technology, right? And not just in our cannabis industry, but in agriculture in general. HID technology has really been the prevailing source of technology for lighting, our crops. And so we take that as kind of our baseline and upgrade from there, right? And so kind of the two categories that we're seeing for retrofit and expansion, the first one being HID to LED, right? And there's a few different modes at which people decide to make that movement, right? Whether it be a PPF match, so we want to save energy, but maintain a similar light level as we're used to. And in the second category right there, which is kind of like a wattage match, it was kind of a catch-all, right? Which is essentially utilizing a similar or same amount of wattage that we're used to utilizing, but increasing our photon density, right? Or our productivity of our plant. Mm-hmm. So those are kind of the two movements that we see people making in an indoor setting when converting from an HID situation to an LED situation. Now there are some other, forms of technology that people are starting to incorporate indoors. I just saw a comment, solar tube is a real big one. And so, there are some other ways to incorporate, more lighting into an indoor setting as well too. But traditionally, when we're speaking of retrofit or expansion, they're moving from HID to some other more efficient form. So the second part of that category of the retrofit expansion is HID to LED multi-tier. Right, so they're used to going single level in their HID setup. They're double-ended, HPS, and they want to go more efficiently, not in just the technology, but also in the space utilization. So they're deciding to go LED multi-tier, and with that, we kind of see both situations: a wattage match combined with additional infrastructure. So. These are kind of like the overall categories that we see as far as decision making for people these days with indoor strategies. Greenhouse is a whole nother school of thought and considerations, but as far as indoor strategies, this is kind of the wheelhouse. I can answer this question in just a sec. If Robert, could you move to the next slide?
Sure.
So within these different decisions and different categories, there it comes, the questions of why are we making this decision, right? And, you know, as Kenda and Rob have explained, you know, previously, you know, in order to make a decision financially, there has to be a purpose for it. It either has to, you know, save us money, save us resources, or maximize our plant production, right? And these are the type of things and the type of metrics that we look at in deciding whether choice A or choice B makes more sense, right? And so this, for instance, in this circumstance right here, it's kind of a snapshot of a one-to-one replacement, right? So in this room, we're replacing 72 double-endeds with 72, you know, LEDs, right? The room PPF is pretty much closely to the same, right? We're losing about 2% overall total room PPF in this conversion, but we're saving about 40% in our light power density, right? So our how many watts per square foot. So in this situation, just going from an HID fixture to an LED fixture, we can see a savings about 40% in energy, right? Canopy is the same, you know, PPFD, like I said, on average for the room is closely to the same. And so let's go to the next slide. So in this next slide, like I was saying, the next, you know, consideration I see people making is a wattage match. They're already used to using so many watts, and their system is designed at so many watts or BTUs or whatever their calculations they're working out previously with their installers, right? So they say, I want to use that same wattage, but I want to increase my productivity and my performance of the plant, right? And so at that point, they'd be going from, you know, if the same situation, to 72 double-ended HPSs to 120 LEDs in this circumstance, right? So we're seeing about the same amount of total electrical input, right? So it's a pretty much wattage match, but we're seeing about a 63% increase in overall room PPFD average, which is that photon density that we're reaching onto the plant, right? So that's another approach people are taking. They are used to using this amount of energy, right? So they might as well continue to use it, but increase productivity by utilizing LED technology to increase that light level, right? And so if we can go to the next slide, we'll see that kind of third scenario that we see a lot, right? Which is a single level HID situation to a multi-tier LED situation, right? And in this circumstance, we're pretty close to the same PPFD as far as on the canopy itself, right? Our total room PPF, which is the amount of photons that are inputted into that room in general, obviously go up 60% because we're adding another level. But the key is that canopy. That canopy goes up about 115%, right? And so that canopy increase, right, we're able to see a slight lighting power density in this one. As you can see, a 53% decrease in power usage, right? But we're increasing that canopy quite a bit, right? Which also increases that productivity every single cycle, right? So these are some of the metrics that we really go into to start evaluating the performance and how optimized one room is or one decision is compared to the next decision, right? And all these are based around how much, what market we're in, how much we're trying to produce, how we're trying to sell it, and what our business model is. We could go to the next slide. So in this slide, it kind of gives us a visual of performance, right? Performance of all four choices, right? And so the first choice, as we see, it's a one-to-one retrofit. And the numbers on the left are kind of arbitrary for this exercise. This exercise is really made to show you the exponential growth that you can see, or percentage of growth from one solution compared to the next solution in an overall payback, right? So as, you know, adding, you know, one thing that Rob said earlier was this decision right now might affect our CapEx, right? And so obviously adding, you know, 2x the amount of fixtures to a room is going to increase that CapEx. It may not increase that OpEx, because we saw we might be joining the same scenario as far as, you know, lighting power density, right? But we're definitely increasing that CapEx because it's going to cost a lot more to purchase those LED fixtures, right? But yet you can see over time the overall payback in ROI is quite increased compared to the rest of it, and that's just because we're increasing that overall capacity of that room and that overall production per year and per cycle. So we could go to the next one. So in kind of a recap on the financial section, obviously it really ultimately comes down, until the borders are lifted here in, in North America, it really comes down to what market are we in and how are we trying to set our business up to be as successful as we can for that market, right? And one thing to look forward to when working with a lighting manufacturer or working with, a consultant, is diving through these details and saying, okay, let's look at 3 different decisions and see what decision is going to make more sense as far as, the money that we have to put up front and the return on our investment. So in order to do this, we have to think about, obviously the best practices. And we're kind of honing in on CEA here and kind of discussing vertical agriculture, being kind of a more optimized approach to certain areas and certain regions for growing agriculture, right? And like we said, as land, diminishes and resources diminish, we have to figure out ways to become more optimized. And in certain locations, vertical farming is just that, right? And for certain crops, vertical farming is just that.
Hey, Casey, can I jump in with a question?
Sure, absolutely.
It occurs to me that the wattage matching might be a smart way to go so that your HVAC isn't undersized or oversized. Is that correct?
Yeah, so depending on the HVAC system, how it was originally built and designed, and the thing about the HVAC is you're right as far as heat loads, right? But another big component that goes into HVACD design is that dehumidification approach, right? And so how did they account for the moisture removal in that room, which is based off of the plant's needs, And so, yeah, we're seeing that a lot of situations where people are matching wattage, the cooling load of that room, the capacity of that room is pretty standard at that point. It's comparable. The only thing that we have to start paying attention to is that if we're increasing that photon density of that light, we're increasing the performance of that light. And so a lot of times we're seeing a need for more fertigation or more water. And so we have to account for a little bit higher transpiration rate sometimes in those situations as well too, because as we're saying, if we're expecting an increase of 1% production for every 1% increase in light, that plant is going to require a little bit more, optimized feeding and optimized watering to achieve that, so we might see a little bit more need for dehumidification at a higher light level as well too.
Great. Hey, and we've got a question from DM on the chat. Says, can you speak to the room's reflectance and the strategy there and how it relates to lighting? Absolutely.
So, everything from the reflectivity of, the walls, the floors, the ceilings, reflectivity, the positioning of your benches, like I said, from single level or for single level static benches to rolling benches, even if we're just talking about single level. All of those choices go into how optimized your lighting is, right? And how much lighting you need to make a consistent light level throughout the canopy, because that's essentially what we're trying to achieve. We're trying to obviously minimize the need for more lights, but more optimize how those lights are deploying photons to the canopy. So, having the walls as much of a reflective surface as you can, obviously a key component, but also designing your lighting, and this is something that Kenda is really well familiar with, but designing your lighting in a way to where you're maximizing the photons that are coming out of your lights onto the canopy itself too. So there's a few things that go into room design that can help maximize, the ability for the light to reach the plant.
Yeah, I got a funny story real quickly that we moved in at Purdue. We moved into a grow room when the facility was opened and realized they painted the grow room off-white like they would all the offices. It's just the standard Purdue off-white office color, and it was going to cost $4,000 to repaint it. And we didn't have the money at that time, but you could measure. I mean, we lost when I put a white piece of poster board up and measured, you could tell we were losing 4 or 5% light because of that silly mistake. And as we talked about, that really could affect your yield.
Absolutely.
Anyway,
and there's a lot of companies now to building, paneling and specific wall types now that kind of can help that reflectivity value, and lessen the need to worry about painting or texturizing the wall, so there's definitely a lot of install types nowadays that are kind of helping us. We don't have to have the Panda film anymore.
Yeah, and before we go on to best practices, I want to make a programming note that Kenda, we will probably jump over the commissioning section, and I will only lightly touch on the benchmarking and considerations for time. If we don't have a lot of questions at the end, then we'll come back and talk about commissioning. All right, that's the end of the programming note. The PSA is over. We'll let Casey continue on with the best practices.
Perfect. As long as there's no other questions on that one. If there are, we can hit those up at the end too. So write them down on your notepads. So a few considerations when deciding, if, when, and why we're going to start, growing vertically as opposed to linearly. And so before we start, a few things, obviously, number one, what the heck are we growing? Like I said before, every decision is based around what you're trying to cultivate. Not only that, but the market and the market's needs, for instance, lettuce, if we take into consideration how we think and approach cannabis, let's grow more, let's grow better, lettuce, there's certain type of lettuce that are sold by the head at a specific rate. So if you grew a gigantic head, you just wouldn't be able to fit it in the clamshell. So really understanding how you're trying to produce based on whatever market your needs are dictates how you grow, right? And then again, just like the financial considerations, your business model and financial plan, right? Having a solid business model and a solid financial plan moving forward, obviously with Kenda, seems like 50% padding on numbers these days. But having a solid business model and financial plan is a real key to success. So then we talked about space utilization. So size and multi-level, how many levels do we need to grow? What type of crop are we growing? What phase of that crop are we growing and needing to be multi-level and extend upwards as opposed to outwards? Those are some considerations that need to be made when designing that facility plan. As we go up, we start to see some changes in how our environment interacts, how we're able to actually install and utilize and deploy equipment in the room, such as dehumidification, fans, irrigation, those type of things. So the higher we go, the more considerations we also need to make on how that affects the overall system of our production facility, right? How does it affect the HVAC and the dehumidification? How does it affect our airflow? Those type of things. Not only that, but how does it affect our employees? Going up and down ladders, is it safe? Is it efficient? Those are all type of considerations that when we go up, we need to make, to achieve really solid plan moving into it. Types of things like fixture mounting and wiring installation, all of this needs to be cohesive and work together, and previous to, I'd say within the past couple of years, a lot of these groups, the electricians, the plumbers, the contractors, they all kind of work siloed, but through a general contractor, right? Now, as we're starting to develop more integrated systems that rely on each other's success, we're finding that a lot of the manufacturers are starting to work a little bit and develop their products a little bit closer together to have a little bit more cohesiveness in the field, as opposed to having a bunch of different systems that work independently, even if you have a main site controller, So lately we've started to see a lot more cohesiveness amongst, manufacturers in designing equipment together, and wiring and mounting installation goes within that. So the next consideration is zones and controlling. Do you need to control these fixtures? Do you need to dim them? Are there multiple stages and ages of plants within the same room? And how does that look as far as scheduling and, and light intensity? So those are some considerations when designing a room, but also a vertical facility. Do I want, each rack to be zoned on a group together for dimming? Do I want each level? This is all set forth in basically our design, and how we want to move the plants through the facility efficiently. Intensity and spectrum. These go along the lines of what crop am I producing? What phase is it at? And what am I trying to achieve within that crop? And then last, but absolutely not least, is, GMP considerations, compliance. If we're starting to see products that we're creating shipped abroad, there's certain certification levels of cleanliness that we need to start implementing, within our facility and our products to achieve those standards. And also incentives. We've seen in many of the markets nowadays, there's rebates and incentives for growers to optimize and become more efficient with their production, and we're seeing a lot of incentive programs paying for portions of these installation costs or equipment costs. So, optimizing your considerations based on those things are really crucial as well too for saving money. Next slide, please.
Yep. 1 second. Oh, there you go.
Perfect. So LEDs for vertical growing, and Kenda touched on some of this a little bit earlier when she was talking about form factor and whatnot. But just kind of an outline, fixture design is really crucial. There is not one type fits all light like we previously had in the HID days, right? There is a light, a form factor, a build, a deployment for every single type of scenario, and when choosing a lighting manufacturer and a partner, it's really important to know that you have a portfolio of products that can work for whatever your needs are, right? Not just one or two types of fixtures that can be adapted to every scenario. The days of adaptation are done, right? We have specific lights and specific fixtures now built for purposes, right? Am I growing a crop or a size of crop that needs a combination of top lighting and intercanopy lighting, right? We're developing lights, we as far as a community are developing fixtures now to go under and also within canopies to try and boost the performance of the light, not just necessarily directly from above, but also within. Is this something that's applicable to your production type or your needs, your business model? Controls. What do I need as far as lighting controls? Do I need to, increase intensity, decrease intensity? Do I need on and off functions? Do I need spectrum controllability? What are my needs based on what my crop is and how I need to maximize that? And then as far as the phases of growth, right? What am I trying to achieve with this fixture? Am I growing seedlings? Am I growing clones? Am I using this fixture purely for vegetative results, or am I trying to produce flowers and fruit with this, or flowers or fruit, right? So these are all type of considerations that we need when choosing the fixture for the specific application that we need it for. All right, and one of the things that we're talking about so heavily these days is light intensity, right? If we can go to the next page. So all plants require different types, different amounts, different colors, different performance of lights, right? And this chart right here is kind of just an overall approach to show you the differentiation between different crops in the lighting needs. And like Rob explained earlier, DLI, is traditionally used in agriculture because traditionally in agriculture, we had help from the sun, right? So we counted things as far as how many micromoles are touching that plant throughout a 24 period of time, right? Or that growth rate, or that growth period of time, right? And so this is how many moles per day. And so you can see that, you would use a completely different approach if you were growing, let's say a rose or some lilies or lettuce compared to tomatoes and peppers, those type of things, right? So each plant requires a different light intensity need to maintain optimal performance. And if we can go to the next slide, we'll see kind of an anecdotal chart that we use for cannabis production. So as you can see, there's multiple phases of growth, and those phases of growth require some different approaches within the lighting, right? And as you can see here, the lighting intensity is really the thing that we're trying to highlight the need to be aware of as far as how we're steering that crop through its life cycle for success, right? And so you can see we go from a long day plant, an 18-hour photo period, in this scenario to a 12-hour. And I know there's a lot of other scenarios that are being tested out there and tried, 20 hours on, this off. A lot of things, but we're talking kind of a traditional sense here from 18 to 12, and then how we ramp up the photo period. If we can go to the next slide. So one of the hot topics, and Rob kind of touched on this a little bit earlier when he talked about the plant's responses to different wavelengths of light. There's different spectrum choices for different crop applications, right? Whether you're trying to bring a color out in a basil, or whether you're trying to bring an aroma out in a rose, there's different approaches that we'll take as far as spectrum and intensity, right? And so crop type is really key in understanding first how to utilize spectrum and how much of that spectrum to utilize, right? So then the facility type, if we're growing in a greenhouse, our lighting supplemental design might be slightly different than if it's sole source lighting, right? We might choose a different spectral application because we're adding to what the sun is not giving us at that point in time, right? Compared to indoor, where we're relying on that light for sole source lighting, right? So facility type is really key, whether it's greenhouse or indoor, and understanding how to utilize spectrum. So in the whole world of spectrum, in the spectrum of spectrums, there is, an increasingly kind of more separated approach. There's a broad spectrum category, and then there's the narrow band spectrum category, right? Which we traditionally saw in floriculture and agriculture in the earlier onset of the LED technology, right? Broad spectrum we're seeing being utilized highly, in the cannabis production these days, and seeing the best and most consistent results, throughout the vast world of cultivars that we're testing and chemovars that we're testing, and this is one of the highest challenges with cannabis that we face, that we never really faced as much in commercial agriculture, because in commercial agriculture, genetics were bred a little bit more homogeneous than we have within cannabis. So even one cultivar could have, hundreds of different phenotypical expressions based on, how we implement certain colors and intensities, right? And so the spectrum and intensity go so hand in hand. And like Robert said earlier, at low levels, we're able to see these maybe positive effects and changes on a plant's morphology, right? But when given the plant at an increased level, we might see some poor movements forward as far as plant morphology and performance. So spectrum and intensity are really closely tied together on how positively or negatively they affect a plant or a part of that plant's production. And so custom spectrum, I just kind of put this on there. Custom spectrum is, one of those things that is an absolute moving target these days, and why, some manufacturers have implemented this into their products, and a lot of manufacturers have not implemented spectrum changing, control into their products, and that's one thing that we're still community wise, studying the effects on altering spectrums throughout, phases of growth, and how to maximize that for results, right? And like I said, and spectrum and intensity go so hand in hand together, and we're seeing certain things as far as, introducing higher wavelengths, higher percentages of certain wavelengths at a higher intensity, and what that does as far as the plant growth. So this last term is a term that gets kicked around quite a bit. It's efficacy, and Rob touched on this earlier. It's essentially how efficiently that the amount of light is interacting with the amount of power that it takes to provide that amount of light, right? And the efficacy is what that's called, right? And so to be a part of, the DLC, for instance, they require a specific efficacy level, right, to be able to be certified as an efficient lamp or an efficient luminaire, right? And so, we call this spreadsheet chasing or info chasing. A lot of people will try to, use the highest variable that they can. We get a 3.3 or a 3.6 efficacy value, micromole per joule, but that doesn't really tell you how optimally that light is going to be for that plant, right? Like I said, spectrum and intensity work really hand in hand together, and you can alter the efficacy by increasing certain areas of the light wavelength that don't need as much power to produce a high amount of photon level, right? So red is a very efficient wavelength, and we see a lot of high reds. As you can see here in 6 different examples, the 5 out of the 6 have a really high red component, right? And red is a very efficient color, right? But at a certain intensity, without the rest of the wavelength, it becomes very problematic for the plant and very problematic for specifically cannabis flowering production. And so efficacy has to really be kind of finally looked at based on what the intensity and spectrum is available for the plant. So that kind of gives you the roundabout as far as considerations for multi-level, intensity, spectrum, and application base.
Fantastic. Thank you, Casey. There aren't any questions in the chat, but Mary from PG&E has sent us a great link about a tool that they have in their library that you can measure that spectrum with.
Perfect.
Next, I'm going to, in the consideration of time, I'm going to jump to the SCE incentives, and I want to remind everyone that you'll get an email that has this entire deck in it. So we're not going to go through the commissioning or the controls or the benchmarking right now, but you can look at those slides and contact us with your questions, and we can contact our panelists in case there's some questions you have about that. I'm wondering if Christopher Scott is with us.
I am here. Can you hear me?
Yes, Christopher, thank you for being here. Christopher Scott of SCE is going to talk to us for a few minutes about the new lighting incentives they have. And just let me know when you want me to advance the slides, Christopher.
All right. No, I appreciate it. And I apologize to everyone for being a little bit late coming onto your presentation today. My computer wasn't letting me onto Zoom, so I'm actually using my personal phone to be able to watch the presentation.
Right. Thank you. Go ahead.
Oh, no problem. So for our particular program, which is called the Summer Reliability Program, it is a special program that we implemented in a very short time frame. We have yet to find a proper home in any of our in-house or third-party run energy efficiency programs. And we were required to develop a summer reliability program centered around energy efficiency. And with that, we were able to get indoor horticulture measures approved for this program. Did you receive my updated slide deck with a one-pager, or is that something you're going to send out with the presentation?
Yes, I believe.
Perfect.
Is this the right one here?
Yes, it is. Thank you.
Right, thank you.
So this is a very high-level overview. We have a lot of program information that is available, so you can contact me offline, and I'll show you how to do that later. But this is a performance-based energy efficiency program that's designed to reduce energy consumption during peak hours during the summers of 22 and 23. But you can also reduce energy consumption during non-peak hours and during non-summer time periods. So it is a great opportunity for people that have been struggling to make energy efficiency improvements without incentives, and utilizing this incentive to help influence you to move forward. This is your best shot right now as an indoor horticulture customer. This summer reliability program is statewide. So Edison, PG&E, and San Diego Gas and Electric are both offering the program. Our program designs will differ. So you would definitely have to reach out to the other IOUs if you also happen to be in their service territory. But Edison has a $60 million program budget. And that's for this year and next year. That is really, really a substantial budget. That's to run the program, and that's also to offer incentives. It's got a streamlined application process compared to our past programs. And we also don't have to do pre and post audits or site inspections. We do hold that open because we may need to do inspections in case we ever get audited. But this program is a great streamlined program with a lot of funding available. This is a trade professional driven program. So if you're an end use customer of Southern California Edison, and it's your facility that the crops are being grown in, you'll need to partner with a trade professional who it's what we call a vendor or implementer as well. They are the ones that are going to get compensated based on the performance of the energy efficiency measures. The performance is tied to grid benefits, but it roughly comes out to about 30 cents a kilowatt hour. And then whatever agreement you would have as an end use customer with a trade professional for how you're going to get incentivized or compensated would be between you and your vendor. Edison's only agreement will be with the trade professional. It's based around, LED fixtures, but if there's also incremental HVAC savings, that can also be counted towards the energy savings. And the LED fixtures do need to be listed on the Design Lights Consortium eligible product list. Next slide, please.
Oh, is this one that you didn't provide? I may
This
have.
is one that I did not provide, but let me real quick give some contact information if you don't mind.
Yeah.
If anybody would like a little bit more information on how to get our program materials, please email me directly. It is summerreliabilityprogram@sce.com.
Great, and I'll ask Carmen to put that on our chat as well.
So
Hey.
we're trying to do quick turnarounds, but if it's a day or two, please bear with us. We're getting a lot of interest, and this is not my only program.
Right. Thank you so much, Christopher Scott. The $60 million budget for the summer reliability, that is remarkable, and I hope growers will take advantage of that. Was there anything else you want to talk to us about today?
Nope, I think everything else is available via our website, and like I said, I'll send you all the information if you reach out to me.
Great. And Carmen's already got that website up there. She's right on it. Thank you, Carmen. Okay, well then thank you again, Christopher, and we'll jump to see if there is any questions that folks would like to ask us. Either raise your hand or you could write it into the chat. We've got a few minutes here. Okay, I tell you what, since we've got a couple minutes, let's see. Kenda, would you like to talk to us about controls or commissioning for a couple minutes before we sign off?
Sure, love to.
Which one?
I'll talk about the considerations. Actually, you know what? Let me go ahead and skip to the last. Let's click to the second to last slide.
Of the
That's just in terms of equipment.
Yeah, is it
control equipment?
Do you have a number on that slide by any chance?
Oh,
or is it in the commissioning section, or is it in the
it is in the commissioning section. I think it's the second to last slide.
Great. Oop. How about that one? Is that it?
Yeah, that's great. Yeah, I just basically want to touch on, so with control systems, there's a wide variety of options. There's more in-depth, building management systems that can be customized for your grow space. And that's, means the number of sensors, adapters, meters, stations, all of that can kind of be dialed in based on the size of your facility and what you're growing. But the accuracy of the measurements can depend on how and where measurement devices have been placed. So just last year, IES put out a guide on recommended practices for horticultural lighting. And when it comes to PPFD uniformity and recommendation and all of that, plus or minus 10% from the average. So that's based on multiple points across the canopy, not necessarily just in the middle of the grow. So take this into consideration when you're actually placing your sensors for measuring light intensity. The other thing that I wanted to kind of mention, and this is something that I've kind of come across in visiting, some of the grows throughout the years, when you're using handheld sensors or stationary sensors that connect up through a more, advanced system, make sure you're using the correct settings for your light type and make sure it's calibrated. This can be huge when it comes to making sure that what you're seeing, what the readings that you're seeing are actually accurate. So for instance, make sure that your sensors are intended for lux, PPFD versus lumens and candela. And then make sure that they're dialed in specifically for your spectrum. So this can actually mean you may need to apply correction factors based on your light's QPD, because that can vary depending on what was used to calibrate the actual sensor. This can factor into the accuracy of your measurements. And so if you check with the manufacturer of the sensors, some of them have guides and tools for the correction factors. You can actually submit your spectral distribution to generate a unique correction factor for your particular setup. And I mean, in terms of, you know, how much of a correction might be needed, it could be as little as, you know, a couple of percentage points, but I've seen, you know, up to 30%, just depending on the spectrum of your light versus what was used, you know, to calibrate that equipment. So that was one of the main things that I just kind of wanted to touch on, because all of that factors into, you know, making sure that your readings are accurate and your automation, which is going to be based on your readings, is working optimally for your growth.
Kenda, that was spectacular. I'd not heard of that before. Correction factors. Thank you for bringing that up, and thank you for being light on your feet to go with my asking you on the spot. Kenda, could I ask you, one of the questions that's popped up on the chat is the UV spectrum of light necessary for growing cannabis indoors? Can you answer that for us?
There's going to be a little bit of UV in most broad spectrum, or really most lighting in general, unless, you know, there's a specific, unless you're specifically dialing it out. But I would say it's not as necessary as blue or red, but there are some. I would say there are some benefits, but I wouldn't say it's like absolutely necessary.
Yeah, from what I've been reading, the science in this, it seems to be some studies show a benefit and some don't. So at least to my reading, it's a little bit of a mixed bag. But I'm not the final say on this. Casey Rivero has Fluence looked at UV light and have any advice on whether or not it's necessary?
We have been, we've been studying it, you know, in combination with, you know, broad spectrum and other spectrums, when to use it, how much to use it. Results are all over the place right now. But we've partnered up with a company based out of New Zealand that has done a lot of intense studies on the use of UV, specifically in early plant production phases. You know, in seedling and in clone phase, and small amounts of treatment, and are seeing some really interesting results right now. And so, you know, nothing as far as coming out on white paper with cannabis, but we're working towards, you know, understanding how to utilize different components of the spectrum at the best times. So.
Right. Thank you both for that update. It sounds like it's still not. Well, the answer is no, it's not necessary, but there's a lot of intriguing research going on. Before we leave today, I want to remind everyone, all our attendees, that we have two more workshops for this series, one on HVAC on November 8th and one on controls and automation on December 13th. Our sponsor for this webinar is Southern California Edison. We do want to thank them for partnering with us, and this was just a fantastic, I learned so much, a fantastic webinar. Also, I want to let you all know that if you go to that virtual classroom, you'll also see dates for more workshops, which PG&E is sponsoring. So those will be on HVAC for craft cultivation, December 8th, retrofitting, March 14th, water circularity, March 28th, peak loads and renewables on the April 18th, and case studies on May 2nd. So a lot of opportunities there in California to learn more about resource efficiency in CEA. So we need to sign out now. I want to thank Kenda Branch and Casey Rivero for being our panelists today, and also again SCE for being our partner, and for Carmen Azzaretti and I at Rob Eddy for Resource Innovation Institute. Thank you so much, everyone. This has been a great webinar, and glad you were able to join us for it.